Now let's look at the derivative of another inverse trig function, the derivative of inverse sine. We will do so by finding the derivative of the inverse sine of x squared. So notice here I've used a different notation for our inverse trig function. This -1, that's not really a power, but a notation that we're taking an inverse of the sine function, just like we did with f to the -1 to represent f inverse. And my argument here is x squared, which is a little bit more complicated than just using an x. We're going to continue to use our inverse relationship between the inverse sine of x squared and sine of x squared that allows us to write sine of inverse sine of x squared is equal to x squared. Now taking the derivative of this equation and applying the chain rule on the left-hand side, we will have cosine of the inverse sine of x squared. Taking the derivative of the inside, we get d dx of the inverse sine of x squared. And we're going to stop at this level because this is what we're trying to solve for, equals the derivative of the right-hand side, which is 2x. Now, just as before, we'll bring this cosine of the inverse sine over to the right-hand side so that we solve for the derivative that we're looking for, derivative of the inverse sine of x squared. And here we see that we have 2x over cosine of the inverse sine of x squared. Now, this formula is not terribly helpful, so we are going to try to simplify our denominator. We're going to use the identity cosine squared of an argument plus sine squared of an argument equals 1 to replace this cosine here. Now, in order to find cosine, we first solve for cosine squared, which is 1 minus sine squared, and then take the square root. So this gives us that the inverse sine of x squared derivative is 2x over the square root of 1 minus sine squared of the inverse sine of x squared. Now let me rewrite this denominator just a little bit so that it's a little easier for us to see what's going on. I'm going to pull that squared outside off of this sign. So I'm changing our notation, standard trig notation of the power here right next to the name, and pulling it outside. So we have 1 minus the sine of the inverse sine of x squared. Now we have a formula for this, and it's right here. We see that the sine of the inverse sine of x squared is simply equal to x squared. So replacing, we get 2x over the square root of 1 minus the quantity x squared squared, which is 2x over the square root of 1 minus x to the fourth. So this is what we solved for. We found that the derivative of the inverse sine of x squared is 2x over the square root of 1 minus x to the fourth. A more general way we can put this derivative for the derivative of the arc sine of a function of x is that the derivative of the inverse sine or arc sine of u is equal to 1 over the square root of 1 minus u squared times du dx. This is our chain rule piece.